What's up, everyone? Today we're talking about chain rule. And chain rule is a super important concept, but luckily it's not too bad. Okay, so a little bit of review on stuff you already know. Here we're talking about composition of functions, right? So it's like where we're plugging g into f. So we have f of g of f of g of x here. So in this case, 3x squared plus 5 to the 7th power, right? So these are what we call composite functions. So here we have a list of like just basic functions. Okay, 5x to the 7th, some trig here. Okay, so nothing too fancy is going on with these, just a basic polynomial. On the other hand, these composite functions kind of have a little more going on. Okay, we consider them a function inside of another function. All right, so I have sine of 4x. 4x is inside of my sine. I have two functions there. A cosine cubed. So this is cosine of x cubed. So cosine is one function. It's inside of the greater function, the cubic function. Right, same thing here. And if I want to actually take the derivative of one of these, I have to consider what's called chain rule. Right, so this is one way of thinking about chain rule, where u is some function, okay, it's being exponentiated. And so if I wanted to take the derivative of this, I would just do regular old power rule for u. Okay, so the exponent goes down, I subtract 1. But then I also have to consider the derivative of u with respect to x. Okay, because in this case, u is a function of x. So I have to take the derivative of u with respect to x that gets multiplied at the end. Okay, the way that your book writes it is right here. So I'm taking the derivative of f of g of x. Okay, so g of x is my inside function, f is my outside function. So I kind of think about this as taking the derivative of the outside, with the inside remaining unchanged, times the derivative of the inside. All right, so see, we kind of went layer by layer here. So I went derivative of f, where the inside went unchanged, and then I don't worry about f at all. I just take the inside, which is g, and take the derivative and multiply it. All right, let's actually work through an example. So here I have the inside, okay, and then the outside is to the 5th power. Yeah, that's kind of how I'm going to consider it. To make that a little more clear, let's make a substitution. So I'm going to let u equal 4x cubed plus 3x minus 2. Right, let's just make that substitution so it's really clear what we got going on. Okay, in that way, f of x is really going to be u to the 5th power. Okay, because I'm just substituting u for all this junk. So I'm just setting u to the 5th power. Well, I can take the derivative of this. Okay, the derivative of u to the 5th power is just 5u to the 4th power. But then because I know u is a function of x, okay, that's how it's defined here, I also have to consider du dx. All right, so let's substitute back in what we know. I know that u is 4x cubed plus 3x minus 2. But I also have to multiply by du dx. Let's figure out what that is. All right, du dx is the derivative of u with respect to x. Okay, so I'm just taking the derivative of what I got here. All right, and that's going to be 12x squared plus 3. So I know that I have to multiply this by du dx, which I just found to be 12x squared plus 3. And that's it. That's it. Oops, I forgot to put a 4 here. All right, yeah, that's it. So this is kind of like my outside, or my f, okay, and I took the derivative of f. And then this is my inside. This is my g, and I took the derivative of g and I put it here. All right, let's work through another one. Now this is very similar to ones that we did in our notes before, where I have a denominator. So I got to move the denominator to the numerator by rewriting with a negative exponent. All right, same situation. I have an inside function and then I have an outside function. So let's take the derivative of the function as a whole first. Okay, I'm just going to do power rule. So I have something to the negative 2nd power. So let's take the derivative of that something to the negative 2nd power. Okay, negative 2 times negative 7 is positive 14. Okay, whatever's inside stays exactly the way it is. And then I subtract 1 from my exponent. And I'm going to multiply this by the derivative of my inside, which in this case is just 2. Right, we could simplify more, but I'm not gonna. And let's keep going. All right, so now we have a whole list of crap you gotta memorize. Right, this is all listed in your book. So you do have a formula sheet always available to you. It's all in your book. And it's stuff that we've kind of already talked about. So here, cosine of u, except now we got to consider du dx. So if u is some function of x, we also have to do chain rule. Right, but it works pretty much the same way. So let's work through an example. I got sine of 5x squared. So I'm going to take the derivative of the whole thing first, like the outside first, which is sine. So the derivative of sine is cosine. And remember, the inside doesn't change. Then I multiply that by the derivative of the inside. So the derivative of 5x squared, which is 10x. All right, and let's keep going. I'm going to take the derivative of the outside first. All right, so I need to take the derivative of cosecant, which is just negative cosecant, and then cotangent. Right, so the inside did not change, even though I had to write it twice, the inside did not change. Now I multiply by the derivative of the inside, which is 35x to the fourth. All right, let's keep going. All right, now we got one that's layered 3 times. Okay, so I know that the exponent being there is kind of weird for trig functions. I don't know why they did that. But here I have cosine of 5x to the fourth power. So I actually have 3 layers here. I have an exponent. So my exponent is my first layer. Then I have cosine. And then I have 5x. Okay, so these are the 3 layers I got to deal with. I got to take the derivative one at a time. Literally one at a time. All right, so first let's deal with the exponent. That's just going to be power rule. So I'm going to drop the 4 down. The inside does not change. And then subtract 1. And now I multiply by the derivative of the inside. So now I'm going layer by layer. I'm just dealing with cosine of 5x now. So the derivative of cosine is negative sine of 5x. Again, the inside does not change. And now I have to multiply by the derivative of the very inside, which was 5x. So I get 5 to be my answer. Right, and I believe, yep, that's it. So I will see y'all later.